All right, welcome to section 9.2. We're going to be talking a little bit about the tests about a population proportion. We're going to be figuring out how to find that p-value in this section. So as we continue on, again, remember our random 10% large counts conditions. We got to do that to make sure that we're normal, right? And then we can use the z-tables. That's what we're going to use to calculate a p-value for a test, and then we're going to perform that significance test and then talk about the power of significance tests and describe what factors affect those things, and we're going to talk about those. So remember the conditions that we had before. Again, make sure it comes from a random sample, that the sample size is less than 10% of our population, and that both the sample size times our proportion and sample size 1 minus proportion are at least 10 or greater than 10 is what we're looking for, greater than or equal to 10. So we know what those are. Now, because we assume the null hypothesis is true when performing a significance test, we use the parameter value specified by the null hypothesis. That's why we use p sub 0 when checking those large counts conditions. All right, so for a test, use the null value p sub 0, not the sample proportion p hat to check large conditions. That is expected count of successes and failures. Okay, so here we go. We're going to look at this problem. According to the U.S. Census Bureau, the proportion of students in high school that have a part-time job is 0.25. An administrator at a local high school suspects that that proportion at her school probably maybe less. She would like to carry out a test at the 5% significance level. And so the null hypothesis is that p is actually 0.25, and the alternative hypothesis, of course, is that p is less than 0.25, and p is the true proportion of all students at the school who have a part-time job. Now the administrator selects a random sample of 200 students from the school, excuse me, and finds that 39 of them have a part-time job. Now let's check our conditions. All right, first of all, is it random? Yeah, of course, a random sample. We just did that. 10%. Now 200 is, yeah, it's less than 10% at a large high school. We can assume that. If you think, it depends on what you think large is, I guess. And then if we go n times p, so 200 times 0.25, yeah, that's 50, and 200 times, well, 0.75 would be 150. So those are both bigger than 10. So we meet those conditions. And that's something we've done before and hopefully you're comfortable with. But that allows us to use this. Now, a basketball player claims to be an 80% free throw shooter. We talked about that before. You think the player is exaggerating. All right, so we have the null hypothesis is that p is equal to 8.80, whereas our alternative hypothesis, we think it's less. And yeah, don't, somehow this changed on the slide. Disregard that. That's going to go on to our later problem of what we just talked about. But let's refer to those as 0.880 and on both of those. So when the so we're going to say if the null hypothesis is true, then what values of p hat should we expect in a random sample of 50 shots? Well, because the large counts condition is met, the sampling distribution should be normal. All right, so then we know the center is going to be the same as the population. The mean is going to be 0.80. And then remember to use our standard deviation, remember off our little sheet there. Again, we use this for when we're given a proportion. So we're going to take 0.80 times 0.2 divided by our sample size. Don't forget to take the square root. Time and time again, I remind you, that's where people forget. So our standard deviation of that sample is going to be 0.0566. All right, so now let's take a look at what we have here. Now in this example, now here's our mean, here's our standard deviations. Well, okay, so now we take a look. Now let's say the player makes 32 out of 50 shots, proportion of 0.64. Well, we're looking right down here, and we're saying, all right, yeah, we're getting close to that. I don't know, it doesn't seem overly likely to me. And so we're going to compute the z-score, so 0.64 minus our 0.80 divided by the standard deviation of that sample, remember. We get negative 2.83. Now, since we said it was approximately normal by doing our three conditions, we can now say that that z-score is in play with negative 2.83. It's called the standardized test statistic. Okay, and it basically measures how far a sample statistic is from what we would expect if the null hypothesis were true. Now, in standard deviation units, that is. We use that standardized, basically it's just like finding that z-score. It's our statistic minus the parameter, in this case it was the proportion, divided by that standard deviation of that statistic. Okay, we've done that many, many times. So looking at a standard normal curve, we see ourselves right there at negative 2.83. Now, we can find that probability, that p-value, using table A. We've done that before, or remember our technology. Now, again, if we look on our table, negative 2.83, you should see that that percentage is 0.0023, very small and below our 0.05. Again, if we use the calculator, we can do the normal CDF. Again, we're adding those up, of course, and again, we have that on top here, so we could certainly find those as well. So, yeah. So now let's go back into our excuse me, into the problem with the administrator here. Now, in the preceding example, the administrator at the high school said that, well, we thought at the 5% significance level, the null hypothesis is that 25% do have a part-time job, but the alternative is that it's less. All right, so we had all the details. Now explain why the sample result gives some evidence for the alternative. Well, yeah, again, we have 39 out of 200. That's going to be a proportion of 0.195, which is less than the national proportion. So we're saying, yeah, it looks a little bit less. It's enough evidence to say, well, maybe, something to look at. And again, if we find our z-score, we take our 0.195, that was our percentage, minus the null hypothesis proportion of 0.25. And then remember to find the standard deviation of that by taking 0.25 times 0.75 over our sample size of 200. We get a z-score of negative 1.80. All right, now looking at our table, we look at that, and again, that probability of that percentage that we have is 0.0359. Again, we could use technology as well. The table's fine. We can use that technology as well. And yeah, we find out, wow, 0.0359. So the conclusion is, well, since that's less than our 5% significance level, since it's less, we're going to reject the null hypothesis. We have a convincing evidence that the true proportion of all students at this large high school who have a part-time job is less than 0.25. That's what we're going to go with in that case. So that's that first part. We're going to split this section into three parts. I'm sorry. So there's some problems on page 619, 35, 37, 39, 41. It's a good start to this section. And then we'll come back and do part 2. So until next time, I'm Tom. I'm Mr. Boone.